Today we're looking at expressions and variables. So some important vocabulary. The first words are numerical expression. Numerical means that it has numbers and operations. Anytime I say operations, I'm talking about addition, subtraction, multiplication, and division. A variable can be any letter that represents a value, for example, X or Y or W. A variable expression, well, that has letters and numbers in it. When they say evaluate, this is really important. Put a star next to that, because in algebra it's actually a two-step process. First, we have to plug in the values that were given, and second, we have to simplify, and we're supposed to use order of operations. And then a verbal model is something that helps you translate from words into symbols. Example 1, evaluating a variable expression. When they say variable, that means there will be a variable in the expression. An expression is different from an equation. An expression means that there is no equal sign. An equation is when there's an equal sign. So here the expression is 3 times b. So they told me b equals 90. I'm going to plug in 90. 3 times 90 equals 270. And notice when I get an answer that I want you to look at, I'm going to box my answer in green. Example 2, evaluating expressions with two variables. So again, evaluate means substitute the values in and then simplify. So x plus y, in this case x is 9 plus y is 5. 9 plus 5 gives us 14. Now look at example B right here. X, y. When x is right next to y, that means to multiply. So 9 times 5 gives us 45. And again, box your answers when you're finished. I'd like you to add example 3 right here. This is more of a pre-algebra example. I thought the others were a little bit easy for you guys. It says evaluate when a equals 14 and b equals 4. And the expression I'm giving you is 5a over a minus b. So the first thing I want you to do is notice that I substituted the values in. 5 times 14 over 14 minus 4. And then in a complex fraction like this, we want to always simplify the numerator first. 5 times 14 is 70. And then simplify the denominator second. 14 minus 4 is 10. And the last thing we do is divide. 70 divided by 10 gives us our final answer of 7. Checkpoint. Evaluate the expression when x equals 8 and y equals 2. So look at number 1. All I had to do was substitute an 8 in for x. So 8 plus 12 equals 20. And I box my answer. On number 2, I would substitute the 8 in for the x minus the 2 in for the y. So 8 minus 2 gives me my answer of 6. And on number 3, x over y becomes 8 over 2. So 8 divided by 2 equals 4. And I box my answer. Now, common words and phrases that indicate operations. This is really important. If we just look at addition for a second, addition, the order does not matter. And what I mean by order doesn't matter, if I had 5 plus 7, that's exactly the same thing as 7 plus 5. So order doesn't matter. So when you're using these words, all of these words would tell you to add, but the order doesn't matter. What value comes first in the expression would come first when you translate it. Now, subtraction, on the other hand, order does matter, and that's why I made this note in the margin that I want you to look out. These words change the order. So, for example, minus means subtraction and will not change the order. The difference of means subtraction and will not change the order. Decreased by means subtraction and does not change the order. But here, these last examples do change the order. Fewer than, less than, subtracted from. And so to show you what I'm talking about, look in the margin. 7 minus y, I would translate that in algebra to just be 7 minus y. Nothing changes. But if I use the word 7 less than y, everything changes. Then when I translate it, the y has to come first, and the 7 has to come after the subtraction sign. So it actually becomes y minus 7. Now, some people say, well, what if I forget? Does it matter? Absolutely, because 7 minus 5 would be 2. But 5 minus 7 would be negative 2. So they'll give you two different answers. Now with multiplication, order doesn't matter, right? Because 3 times 5 is the same as 5 times 3. So these words would tell you to multiply, and the order doesn't matter. But in division, order matters. And that's why I put a red star next to divided into. Watch out for that, because that can change the order when we translate. Example 3, write a variable expression. So we're going to actually translate this time. Here's the problem, editing. You have a 350-page manuscript that needs to be edited very quickly. You are going to divide the number of pages among several editors. You want to give the same number of pages to each editor. Use a verbal model to write a variable expression for the number of pages given to each editor if you know the number of editors. Here's a solution. They say, and this is really important in algebra, let E represent the number of editors. That's defining our variable. So E equals editors. And then, of course, divide is going to tell us to use a division. So here's the model. The number of pages for each editor equals the total pages divided by the number of editors. So they told us the total pages was 350 divided by our variable E. Now there's two ways to write this. We can write it using the old-fashioned division sign, 350 divided by E. Or in algebra, often we're going to use a fraction. So I could put 350 in the numerator divided by E in the denominator.